Hello, friends. Welcome to follow up. Let's have a look at today's daily challenge problem. Problem 5, longest palindromic substring. In this video, our plan will be the following. So we are going to present two solutions. So the first one is based on dynamic programming, and the second one will be based on palindrome generation. So the second one is something like two pointers. So with that said, first, let's look at the problem statement, which is very short. So given a string S, we want to find the longest palindromic substring in S. So we want to find the specific substring. So for example, here in example 1, so we have BABAD. So we can see BAB is 1, right? So also we know ABA is another one, right? So, but for this problem, I guess we can return any of the longest palindromic substrings. But some problem, we can have an easy variant. For example, find the lexicographically smallest one or largest one, right? So in the second example, we have BB. So this palindrome has length 2, right? The even length. And the first one, by the way, is odd length. So here the constraints are the following. First, so the length of S is bounded above by 1000. So this basically tells us that n-square algorithm can basically pass the tests because n-square is bounded above by 10 to the power 6. So a typical computer nowadays can treat 10 to the power 7 operations in a second. So with that said, let's look at coding. So first, I'm going to present a solution based on dynamic programming. So here, I'm going to use dpij, so to represent if starting from index I and ending at index j. So if this substring corresponds to a valid palindrome. So I'm going to store this dp table as a two-dimensional binary or Boolean table. So now let's look at the logic here. So first, I'm going to make some preparation. So for that, let's say maximum length. So you can set to be 0 or 1. So if it's empty, it's 0, but here it's supposed to at least 1. But here you can make it 0 or 1. So let's make it 0. So now here n is the length of S. This is just for convenience. And also let's use answer originally empty. So that's why I see max length and the answer always in correspondence. So now let's initialize the dp table. So dp, so 0 times n, right, for a dummy index in range n. So here, this actually is important. We cannot use a multiplication outside the outer bracket because list is mutable, right? So with that said, let's look at some special case. So one character one. So the one character ones are automatically, palindrome. So we can do something like this for I in range n, right? So we just need to set dpri to be true or to be 1. Let's use true here. And the answer will be si. So there's a lot of redundancy. You can choose any of one of them, right? So now let's use this, and the maximum length will be, in this case, always 1. This is one case I just want to present to you. Another case is a two-character case. So we consider I, and then we consider I plus 1, right? So in this case, let's see, for I in range, so I'm going to start from ending at n-2. So we write n-1 here. And then for j, so let's so here I just need to consider if si equals si plus 1. So in this case, I set dpi I plus 1 to be true, right? So this one you can regard it as a diagonal element. So this is a sub-diagonal element or above the main diagonal element. So in this case, I'm going to set this answer to be S. So it has a length 2, so I just add 2, right? So then the maximum length will always be 2 in this case, right? So there's two character case. Then the generic case. So for the generic case, so I'm going to do something like this. For j, let's use j as an end, right? For j in range, so the end can be any index, right? But for index I, so I will say I in range 0 to j minus 1, right? So because we have already considered the equal case, right? So here we use I. So I is starting index is less than the end index. So in this case, so we're going to consider if Si equals Sj, right? And also the substring in between I and j, that is dp corresponding to starting from index I plus 1 and ending at j minus 1. So that's corresponding to dp I plus 1, dp j minus 1. So if this is true, it means this corresponds to a valid palindrome that we can extend to sets. So in this case, so we're going to set dp ij to be true. Right, so in this case, we'll just use a condition to check if max length is less than, so j minus I plus 1, right, the current length. And then we are going to set maximum length to be j minus 1 I plus 1. And the answer will be s starting from index I and ending at index j, so we write j plus 1. So then we just need to do the return, right? So we return the answer. So this is a full solution format to this problem. So before we make any comment or proceed further, let's first do a test. Yeah, it passes the first example. So now let's look at the generic case. Yeah, this is the one. So here, let me comment that. So we can return the lexicographically lexical largest one or smallest one, right? So we just need to make a comparison between the answer, right? So we just, if their lengths are the same, and then we just see if this is a change, and if the length is also the same, and we are going to replace the answer to be the lexical smaller one or larger one, right? This is one comment. So another comment is that we can print out this dp table, this dp. Yeah, for example, for this one, we have this, so here I use 0, so let me initialize as a false. So that's made to be more consistent. So you have something like this, true, false, true, and something, right? So here you can see we just need actually half of the, roughly half of the square, because we always just consider the case when I is less than or equal to j, right? So this is the lower diagonal, lower triangle, I guess. So now with that said, let's look at the second solution format. So it's essentially the same as this one, but in this case, so this one actually the term complexity is O n squared, right? And also the space term complexity is O of n squared. So with that said, let's look at the second one. So for the second one, I'm going to start from index. I'm going to generate the palindrome. For example, for this one, if I start from index 1, so I can push the two boundaries. So because you have B and B, right? So I can push to have 3 in length, right? So similarly, if I have for this one, I can point to 1B and use another pointer to point to second B, and then I slide or push to the two sides to construct palindrome. So actually the second method is very straightforward. Now let's have a look. So I'm going to copy this one, and going to change this function signature to be this. So this is for solution for V1, right? So for the second one, what we want to do, let's first get an answer. That's the empty string, and the length is 0, right? So now what I want to do is for any index for I in range length s, right? So for convenience, I guess I'd better to introduce this length s. So I'll call it m, right? So this I can write for I in range length m. Then our idea is to starting from I, we expand to the two sides. So this we need to consider two cases. One is the even length palindrome, and the other is odd length. So here, let's first look at the odd length. So the odd length, I can point the left and the right to I, so simultaneously. Then basically we just need a for loop. So while left is greater than or equal to 0, and r is less than the length of the string, that is less than m. And then if SL equals SR, right? So in this case, I can expand, right? So basically what I want to do is, so if R minus L plus 1 is greater than length already, right? So we can do length equals R minus L plus 1. And then what we want to do, we can set this answer to be as starting from the left side and ending at the right side. So write R plus 1. So this is just a check for in preparation for the return. And then our logic is to push the R and L to the two sides, L minus 1 and R plus 1, right? So this is the one we check an odd length case, like in example 1. And for even length palindromes, so we can do something like this. So we can set L and R, so we can set this L to be I, and R to be at least I plus 1. So in this case, we do the same thing, right? So while L is greater than or equal to 0, and R less than M, and SL equals SR. So in this case, we do R minus L, check length, right? If greater than the current length, so we are going to update this length to be R minus L plus 1. And in this case, we are going to set answer to be starting from L and ending at R plus 1, right? So similarly, after this check, we always do L and R because L minus 1, R plus 1, right? So then after we finish the for loop, so we can return the answer. So this is the second solution format. But if you see this condition, RL, and then if we expand all settings, L minus 1 and R plus 1, and check the two characters, you see it's exactly here, right? So we check the SI and SG and look at the inner piece. And this means that we can push the substring starting from I plus 1 and ending at J minus 1 to left to I and right to J, right? So then we do the same thing, right? So with that said, let's first test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So I would say that's basically about it for this video. So here, let me give you a quick summary. So in this video, we presented two solution formats. So one is based on dynamic programming, and the other is based on palindrome generation. It's like two-pointer method, but not a the one typically we mean. So I guess essentially they are the same method, I would say, but the different presentation formats actually might be based on different thought process. So with that said, I guess that's about it for this video. If you like this video, you're welcome to share with your friends and also follow up our video channel or playlist to practice more coding problems. But the main effort is in yourself. You need to digest and understand the problem and understand the coding and then practice. So that's it. Thank you.